When a north pole of a bar magnet is moved towards a solenoid of n turns of coil, the following phenomenon can be observed. Here, Lenz's law, end rule, magnetic effect of current, and it is known that current carrying solenoid always behave like a bar magnet. So first let's see the Lenz's law. When this north pole is moved towards the end turns of a solenoid, so what will happen? Here the flux in the bar magnet will link with each turn of the solenoid. Whenever there is a change in flux linked with each turn of the solenoid or a coil, what will happen? An EMF will be induced which produces an opposing induced current which flows in opposite direction and opposes the movement of the bar magnet further inside the coil. So here the bar magnet is the cause. If this is the direction of the bar magnet, then the current will be opposite to the direction. So what is happening? Now, this end of this solenoid becomes the north pole and this end becomes the south pole. We all know that a current carrying solenoid behaves like a bar magnet. So now this bar magnet has two poles. So how to find out the polarity of this solenoid? Using an end rule. So according to the end rule, the end which has the current flow in the clockwise direction is supposed to be the south pole. The other end is supposed to be the north pole. So north pole of the solenoid and north pole of the bar magnet repels. So it doesn't allow the bar magnet to enter further. When we move the bar magnet away from the solenoid, now again the current will be flowing in the opposite direction, so that it makes the bar magnet not to move away. Instead, it will try to attract the bar magnet towards the coil. Here, this current has tried to oppose the bar magnet away. Now here, when I started moving the bar magnet away from the coil, this current will try to attract. So here repulsion, here attraction occurs. So now, any current carrying coil produces magnetic field. So we have seen a magnetic effect of current in this phenomenon. So here we got some formula. The induced EMF produced will be equal to minus n d phi by dt. The minus sign is according to Lenz's law, where n is number of turns of coil. d phi is the change in flux. And this, so when we suppose or assume this turn alone, then the magnetic induction due to a circular coil along its axis will be equal to mu naught Ni by 2a. Also, for any solenoid, the magnetic field formula will be mu N by L into I. N by L is nothing but number of turns per unit length. I think you must have understood. Thank you.